In the previous section, we defined trig functions using the unit circle and right triangles. For each angle, we associate a ratio of a right triangle that was determined by a point on the unit circle. While we defined trig functions for all angles, we mainly focused on evaluating trig functions for angles between 0 and pi divided by 2. In this section, we'll begin studying how to evaluate trig functions for all values. And the title of this section is Trig Functions, Part 2. Before we summarize the topics, let's go ahead and recall the definition of our trig functions. First, assume that P is a point on a circle with radius r and center given the origin. The associated picture looks something like this. Then the trig functions are defined as follows. Here's the first three, and now here is the second set of three. Notice in the second three, secant theta, we can't have y is equal to 0. Oh, excuse me, the secant theta should be an x here, and this cosecant theta should have a y here. And note again that we can't have x be equal to 0 in the denominator, we can't have y being equal to 0 in this denominator, and we also can't have y equal to 0 here either. This section is now broken into 3 parts, and the first part will focus on evaluating trig functions for any value of theta. In part B, we'll be introducing some more trig identities, and then in part C, we'll look at an application of expressing the area of a triangle using sine theta.